Guys, so today we're going to be talking about the binomial distribution. So this is a probability distribution. So it means that using this, we can calculate some probabilities of different events occurring, given that it is a binomial distribution, and we can plug in the formula and be able to calculate some probabilities. So we're going to be going through quite a few different types of distributions in probability. So it's really important that you're able to identify what type of distribution we're talking about. The reason for this is a question. It won't say this is a binomial distribution. You'll just have to identify it is, and then you'll be able to use the formula. So before I go on to actually how we calculate the values, I'm going to describe what actually is a binomial distribution. So just quickly as an example, what an example of a binomial distribution could be is if you roll a dice 4 times and you want to know what is a probability that you will get 3 threes and 1 non-3. So the first thing is there has to be 2 outcomes. So you can think about this as A and not A, or A and the inverse of A, or a success and failure. If there are 3 outcomes that you care about, then you can't use the binomial distribution. As the name says, bi, so it's talking about 2. Even though there are more outcomes, there could be more, such as if you're rolling a dice, there are 6 different outcomes. So that's fine, as long as you only care about 2. So even numbers, odd numbers, getting a 6, not getting a 6, all those are 2 outcomes. But if you said, oh, I care about if there's a 1, 3, or 2, 4, 5, 6, so you care about if it's a 1, you care about if it's a 3, or you care about if it's sort of other, then you can't use the binomial distribution. So the second is the probability of an outcome is constant. So that means that the previous results don't affect it. So if you remember back to conditional probability, this is sort of the opposite. The classic example is the weather. The weather, if it rains one day, it's obviously going to more likely to rain the next. If that is the case, then you can't use a binomial distribution. The probability has to be constant. Such as that's why a dice roll is a common example, because it's obviously constant every time you throw it. The other way it must be constant is that each trial is the same. Now I use the word trial a lot, and so that just basically refers to sort of the number of repetitions of something occurring. So if it was rolling a dice, it'd be each time you roll a dice, that's a trial. So each of the trials, the probability must be the same. Now the third thing is that when we calculate the binomial distribution, it only matters if the order does not matter. That's quite important. So the order does not matter. And that'll become clearer when I do an example later. But when I mean the order does not matter, if I'm talking about rolling a dice, then with the binomial distribution, I can calculate things such as what is the probability that 2 threes will occur. But if you care about the first roll being a 3, then you not being a 3 and then being a 3 again, you can't use a binomial because that's a specific order. And we've calculated probabilities before when there's specific order. Rather, binomial distribution accounts for when order doesn't matter. So you don't mind if it's 3, not 3, 3, or 3, 3, not 3, or not 3, 3, and 3. And so this is really useful because a lot of the time you don't actually care about the order, you just care about the final outcome. So this could be, just quickly another example, is if you care about how many times you win in a season, like a soccer season, so 20 games, you want to calculate the probability that your team will win a certain amount of games, you could do this. But if you cared about the exact order that we win, the exact times we lose, then you couldn't use a binomial distribution. So the formula is that the probability of x is equal to small x, which is equal to n cx times p to the power of x times q n minus x. Now it looks a lot more complicated than it actually is. Well, once you understand it, it's a bit easier and it's a bit easier to remember. So P is equal to the success. So you can assign whatever you want to it, but the P is the success and Q is equal to the failure. So as I said before, you have to have two outcomes. So here are your two outcomes, P and Q. Now, X at the moment is a generic term, but when we calculate it, it will be a specific number. So we'll use a quick example of a dice, where we'll say that P is equal to rolling a 6. So we already know that's 1 on 6, because rolling a 6, that's 1 over total outcome is 6. Then Q is everything else, so that's 5 on 6. So there's two ways to calculate that. You could have said that, well, there are 5 different outcomes out of 6, or you could say that Q is equal to 1 minus P. So Q is equal to 1 minus 1 on 6, which is equal to 5 on 6. Now the reason for this is relating to Q and P are the inverses. So you can think about Q as the inverse of P. And I've already mentioned before the formula that A is equal to 1 minus A inverse. And that is a very important formula, and you can see that here. So we've got the P is equal to 1 on 6 and Q is equal to 5 on 6. And now X just refers to whatever you want to know. So 0, 1, 2, 3, etc. So if I wanted to know the probability of the number of successful outcomes being 2. So let's say that P is equal to 2. So that means I want to know what the probability is that when I roll a number of dice a certain number of times, 2 times 6 will occur. So that is what X is referring to. And so you can see that you can sub those values in, as I will do. And now N is equal to the number of trials. Now I just mentioned before what the trials are. So the number of, you can think about that as like the number of repeats. So for this example, we'll say that the number of trials is 4. So we're going to roll the dice 4 times. So that means we get 4C2 times the probability of P, which is 1 on 6, to X, which is 2, times Q, which is 5 on 6, to the power of N minus X. So N is the number of trials and X is whatever it is. So that means that is going to be 2 as well. Now an easier way to remember what the powers are is that whatever this power here and whatever this power here is, it's going to add up to the number of trials. And you can see that because X plus N minus X is just equal to N, so the number of trials. So whatever this number is, plus this number, has to equal the total number of trials. And that's why I said this formula looks difficult initially, but a lot of the interrelated, once you see a question, will be easier to apply. So that's how you do it here. So what's this C? If you can't remember what the C is, this is the combinations or the combinatorics that we mentioned before. If you can't remember, look at the previous videos, and I'll briefly go through it now. But if you have any more trouble, just go back and remind yourself. So here we have C2. So what this means is that in general, we have NCX. So that is N factorial over X N minus X. So once numbers are put in here, it's a bit easier to see. So you put whatever is at the top, so whatever N is. So the number of trials is 4, so we go 4 over x, which is 2. And then we go 4 minus 2 factorial. And then this is equal to 4 times 3 times 2 times 1 over 2 times 1 times 2 times 1. Cancel these out and we get 12 over 2, so it equals 6. An easy way to remember this one as well is that whatever this number is plus this number must equal this. And that's how you worked out it was the difference. So if we do another example, let's say 10c3, we get 10 factorial over 7 factorial, 3 factorial. So the 3 is from here, the 7 is the difference, and the 10 goes there. And just quickly and important, if you don't know, that 0 factorial is equal to 1. So you don't need to understand why in this course, just remember that 0 factorial is equal to 1. So by implication, that means that things like 10c10 will equal 10 factorial on 10 factorial, which will equal 1. Times, it will be 10 factorial on 10 factorial times 0 factorial, which will just equal 1 because of this. Thanks for watching, guys. So there's a video later on that will go through the binomial distribution, and you should watch this because then you can see the actual formula being used, and you'll also be able to see the type of question in which the binomial distribution is actually useful and can help you calculate a probability. So here's just a summary of the formula, so make sure you learn the formula, and remember in terms of memorization, and for it to be a bit easier to remember, that the probability of P and Q must equal 1, as well as these two top ones up here must be equal to the number of trials.